Hi, so meet you guys again in the last part of tutorial 1, simple harmonic motion. For those who don't have the copy of the tutorial question, you guys can refer to the link I've attached in the description below. Okay, so that you can see the whole question for the tutorial 1. Right, let's move to number 8. The equation of motion for a mass at the end of a particular spring is x equals to 0.3 sine 2t m, 2t meter. M there is basically the meter. Okay, meter is the unit for the displacement lah. Calculate A, displacement at time equals to 0.5 second and 2 second. Right, this question asks for two words. The first word is find the displacement at time equals to 0.5 second. The second one, find the displacement at time equals to 2 second. Okay, that is why you can see I make two calculations here. The first one at time equals to 0.5 second, and the other one is at time is equal to 2 second. Okay, so to answer this question, rewrite the equation given. So I've rewrite the equation given is equals to x equals to 0.3 sine 2t. Okay, then we just substitute the t in the equation there by 0.5 second. And then set our calculator in radian so that we will get 0.25 meter. For the time 2 second, do the same thing. Okay, substitute 2, substitute 2 in the equation, and then set our calculator in radian, and therefore we will get the answer is negative 0.23 meter. Okay. For number 8b, the question asks for the acceleration when its displacement is 0.15 meter. Okay, the question asks for acceleration when displacement is 0.15 meter. Okay, so 0.15 meter is basically the displacement or x. So the question asks for the acceleration. So well, we need to memorize already by heart. General acceleration is negative omega squared x. Okay. When the question asks for the acceleration, the equation must be acceleration equals to negative omega squared x. But when the question asks for maximum acceleration, then the formula will be A equals to omega squared capital letter A. Okay, so for this question, it's just asked for the acceleration, not the maximum acceleration. So the equation will be negative omega squared only. Okay, so obviously to answer this question, we need to find what is omega and what is x. So we've got x here, so we already got x is 0.15. So omega, how do we get the omega? We can refer to the equation given in the question, which is here lah. Okay, omega is basically 2 radian per second. Okay, how do we know? We compare the general equation, because general equation is A sine omega t, right? So that is why we get omega is 2 radian lah. Okay, straightforward. Okay, straightforward get omega is equals to 2 radian per second. Okay, so since we already know what is omega and what is x, so x already given in the meter, so nothing to do with the unit. Just substitute, and then we will get negative 0.6 meter per second squared. Okay, meter per second squared. Okay, so right, number 8C. The question asks for maximum maximum acceleration. Okay, maximum acceleration. This is what I tell you. Maximum acceleration. Sorry. Maximum acceleration. The equation is A max equals to A, capital A, omega squared. Okay, it's a different one to the general equation, to the acceleration only. Kalau acceleration sahaja, equation dia adalah negatif omega squared x. Okay. Tapi kalau A max or maximum acceleration, the equation is omega squared A besar. Okay. So, how do we get a capital A besar tu? Kat mana nak ambil? A besar tu basically the amplitude. So, sama juga. The same thing. We just compare with the general equation. So, we will get A is 0.3. Okay, we get A is 0.3. So, that is why we put 0.3 for A and omega just now is 2 already lah, kan? So, we squared that omega, then we will get 1.2 meter per second squared. Okay. The last one. Last one for number 8. Okay. Sketch the acceleration displacement graph. Acceleration displacement graph. Acceleration displacement graph. You can see this graph in your notes. Okay. So, y-axis represent the acceleration, while the x-axis represent the displacement or x. Okay. So we will get the graph like this. So at the y-axis, we put A max equals to 1.2 lah, because we've already calculated here, right? A max is 1.2. Below is negative 1.2 because it's on the negative side. Oh, sorry. This one should be negative 0.3. This one is positive 0.3. So for the x component, we put the amplitude just now is 0.3. So we can get here 0.3 is amplitude. Okay, so put the 0.3 in the graph here. So at the negative side, we put negative 0.3. At the positive side, we put positive 0.3. Okay. Okay, let's see 8E. Sketch the displacement time graph of the motion. Right, class. How to sketch this graph? The first one, we need to write the equation given. We need to write the equation given. So the equation given in the question is actually this one lah. S equals to 0.3 sine 2t. Okay, so from the equation given, we can get a few information. Okay, the first one, 0.3 itself is actually the amplitude. The sine here is the function of the graph that we gonna sketch. Function of the graph that we gonna sketch, which is graph sine lah. Kan? So graph sine, we know that the shape of the sine graph is like this. Okay, this is the shape of sine graph. Okay, then another one is 2. 2 here is actually omega. Okay, omega. Okay, so there is 3 information that we got from the equation. Now, since we gather all the information, let's sketch x-axis and y-axis. Okay, so x-axis represent the time, where y-axis represent the displacement as the question wants. Okay, So why do I sketch the graph like this? Because the function just now is sine. Okay, because the function just now is sine. Okay, that's why my graph is like this, class. Okay, if the function is a cos, if the function is cos, my graph will be like this. Okay, my graph will be like this. Okay, this is the shape of the cos graph. Okay, this is the shape of the cos graph. Since our function is sin just now, or sine, so that is why we sketch the graph like this. Okay, this is the shape of sine graph. Okay, I've told you before in the previous video that it's better for you to sketch two complete oscillations. So like I have here, this is one complete oscillation and this is two complete oscillation. So I've got two complete oscillation here. That's better. Okay. So for now we want to label our graph. Okay. Since we already have x-axis, y-axis, and the shape of the graph. Okay, now we want to label the x-axis and y-axis. Okay, how do I get 0.3 here? How do I get 0.3 here? Okay, 0.3 here because I told you y-axis is basically the amplitude. Okay, it's represent the amplitude. That is why I put 0.3 lah for the maximum amplitude, and below 1 we put negative 0.3 because it's in the negative side. Okay, so how do we get pi here? Okay, how do we get pi? How do we get pi? Time. So we need to calculate using the equation of omega. So omega is equal to 2 pi f or 2 pi over 2 pi f or 2 pi over t. Okay. So since we have pi, since we have omega here, omega is 2 here. So here is omega. So omega is 2. So we put omega 2 here and equals to the equation 2 pi over t. Therefore, we will get t equals to 2 pi second. Okay, that is why I put t equals to pi second. Therefore, 2t is 2 pi second. Okay, alright. So this is how our graph looks like. Okay, if you don't understand anything, you can screenshot and send it to me. Okay, and you can ask me the question in the comment below as well. So let's see number 9. So we've got a graph in figure 1.3. Okay, shows an example of simple harmonic motion. What is A? The amplitude. B? The period. C? The frequency. D? Write the expression. And A? Displacement at time equals to 7 millisecond. Guys, see the unit there, 7 millisecond. Milli means you need to times with the 10 to the power of negative 3. Okay, so yeah, I've mentioned before, if we got a graph in our question, what we need to read from the graph is actually the x-axis and the y-axis. Okay, the x-axis and the y-axis. What is the x-axis? What is the y-axis? The x-axis represent the time. The y-axis represent the amplitude. Okay, guys. So from the time, we can find the information of the period. Period to complete one oscillation. So period to complete one oscillation. Here is the one oscillation. Okay. So period is 4 lah. Okay. And the y axis here represent the amplitude, right? Therefore, our value of amplitude is 7. So this is amplitude and this is period. Okay. So this is period and this is amplitude. Okay. So we've got two informations in the graph given. Okay, therefore we can answer lah 9A. 9A asks for the amplitude. So our amplitude is 7 cm. Okay, 7 cm is not in the SI unit. In the examination, you need to convert cm to meter because meter is SI unit. Therefore, my final answer is 0.07 meter. Okay. Okay, for B the period. Period just now we've got what here? We've got 4, right, guys? So we've got 4 here. So that's why I put 4. The unit is millisecond. That's why we put millisecond. Okay. This is all the silly mistake that you might do in the examination. I mean, like the unit, maybe you carelessly put second. Okay, maybe you don't forget to put milli there. So carefully see the question, okay, and put the right unit at the final answer. Okay, so C, the frequency. The frequency we need to use the equation of 1 over t. Okay, just now we've got time or period is 4 millisecond. Okay, that's why you see here my t here is 4 times 10 to the power of minus 3 because this one I got from the milli unit. Okay, why I times 10 to the power of minus 3 because the unit is milli. Okay, this one also can be the silly mistake in our real exam, okay, where we forget to times 4 with the 10 to the power of minus 3, okay, because we maybe don't notice the unit is millisecond. So that's why I tell you here, read through the question carefully, okay, so that you don't make this mistake in the exam. Okay, so we should get the frequency as 250 Hertz. Okay, class. The D question asks for the expression. Okay, as you know, the general expression is x equals to a sine omega t. Okay, but we cannot just write like this. We need to substitute what is a and what is omega. Okay, that is why we know from the graph a is 0.07 meter, while omega we can calculate using the formula of 2 pi f. Okay, since we already get f in 2c just F in C just now, 9C, 250 Hertz. So we can find the omega. So after we've got the amplitude and omega, so just put the value in the equation. So we get x equals to 0.07 sine 500 pi t. Okay, so this is our expression. Okay, got 1 mark for that. Another mark, if you still remember, I tell you, another mark is when you state where a in meter and t in second. If you don't state this sentence, then you will lose 1 mark. Okay, as simple as that. Okay, the the question asks for the displacement at time 7 millisecond. Milli, guys, milli. M is milli, stands for milli. Okay, so we need to times 7 with 10 to the power of minus 3. Therefore, just put or substitute the z 7 times 10 to the power of minus 3 in the equation like I did here. Set your calculator in radian, press your calculator and get the answer, negative 0.07 meter. Okay, so let's see number 10. The displacement of a particle in simple harmonic motion is described by the equation as equals to 5 sine 2t plus pi over 3, where x in meter and t in second. When t is equals to 8 seconds, find the displacement, the acceleration, the maximum acceleration, and sketch the acceleration displacement graph for the particle. Okay, for this equation, I've told you again and again, if we get this type of question, rewrite the equation given in the question. So see my work, I rewrite x is equal to 5 sine 2t plus pi over 3. Okay, so when the question asks for the displacement, just substitute the value of time in the equation. So I substitute the value of time here as 8 seconds lah. So I substitute and then I set the calculator in the radian, then I press my calculator and get the answer as negative 4.87 meter. Okay, so for B, the question asks for the acceleration. Okay, for B, the question asks for the acceleration. So as we have gone through number 1 to number 9, you guys should know by now that acceleration is equal to negative omega squared. Oh, I'm sorry, I did a mistake here. So acceleration is equal to omega squared x. Okay, so what is omega? What is x? Okay, how do we get all this value? Compare or refer to the equation given. Okay, so I refer to the equation given again, which is x is equal to 5 sine 2t plus pi over t. Okay, 5 here is basically the amplitude. 2 here is basically the omega. Sorry, I made a mistake. So 2 here is omega, while pi over 3 here is the phase or side. Okay, in the PDT syllabus, there should be no side, but it's okay. This is just the question. We still can solve it, even though you don't learn this phase thing. Okay, so yeah, from the equation, we can get the value of A and the value of X. Okay, so this is the value of A lah, the one we get by compare to general equation, and this one is X, we get from the equation A as well. So use your calculator and then you will find the answer is 19.48 meter per second square. Okay, for C, the question asks for the maximum acceleration. Okay, maximum acceleration, the equation is A omega squared. Okay, just now is acceleration. Acceleration is only negative omega squared x. Okay, I made a mistake just now. For A max, this is the equation for A max. Okay, this is the equation for A max. A omega squared. Okay, so how we get A here from the general equation here. Okay, so A is 5 and then the omega here is 2 lah. Okay, so we get 20 meter per second squared. Very straightforward question. And then for the last one, the question asks for sketching. Sketch the graph of acceleration against displacement, which is x-axis and y-axis. So x-axis represent the amplitude, while y-axis represent the acceleration. Okay, so you can see the shape of the graph in the notes. Okay, so this is the shape of our graph. Is the straight line graph. The y-axis is A max. Okay, so A max here is 20 since we already calculate in 10C. Okay, and at the negative side we put negative 20 lah. Okay, and for the x-axis, okay, for the x-axis we put amplitude is 5, and for the negative side we put the negative 5 meter lah. Okay, so yeah, that's it for number 10. Okay, so that's the overview for number 10. Okay, so yeah, that's all. Meet you guys again in the next video. Bye.